Welcome you all to week 6 tutorial of differential equation for engineers. Myself Guru Bachan from Department of Mathematics, IIT Jodhpur. I am working in the broad area of fractal geometry and dynamical systems. In today's tutorial, we do the illustration that are based on the properties of the Bessel function. Although the topic that is the introduction of Sturm-Liouville theory has been covered in week 6 lecture, that will be covered. We will going to be covering in the next tutorial, that is week 7 tutorial. So for the time being, we will mainly focus on the properties of the Bessel function. So let me write the first question related to it. Show that j minus nx is nothing but equal to minus 1 to the power n gnx, where n is any positive integer. So as you remember that Gn here is the Bessel function of where alpha is n. So n is any positive integer. So we need to prove that if we replace n by minus n in the Bessel function, then the following relation will hold. So for that, we do the simple approach. We first recall that what is Jnx exactly. So since it's we have to show that. So proof, we know that Jnx is equal to the series m0 to infinity minus 1 to the power m x by 2 to the power 2m plus n divided by m factorial gamma of m plus n plus 1. We know that this is our definition of Jnx. So next we have to prove that j minus nx is equal to the following quantity. So for that, we first write j minus nx, which will be equal to m0 to infinity minus 1 to the power m x by 2 2m minus n divided by m factorial m minus n plus 1. So we know that our series is starting from m0 to infinity, and here in the denominator we have m minus n plus 1. The gamma function is well defined only for positive integers and positive real numbers and negative real numbers except negative integers. So since gamma of this is infinity for, or you can say gamma of z is infinity for z equal to minus 1, that belongs to negative integers. So I will also show that. So the series, ultimately the series is going to be start from m equal to n tend to infinity. So let me justify first of all this statement. So we know that relation related to the gamma function, that is gamma of z, gamma of 1 minus z is nothing but pi by sine pi z. This is our relation. So if you will put here, or you may first rewrite it as gamma of z will be pi divided by gamma of 1 minus z sine pi z. Next, 1 by gamma of z will be gamma of 1 minus z sine pi z divided by pi. Okay, so what you will take here, put z equal to m minus n plus 1. We will take this z, and with the help of this z, we get gamma of m minus n plus 1 is equal to gamma of, if you will put here z, value of z, we will get m minus n plus 1 sine pi times m minus n plus 1 divided by pi. So from here you will get n minus m sine pi m minus n plus 1 divided by pi. So since we are talking about, we are just want to claim that our series is going to be start from n to infinity. So that means m can, we just want to make those factors 0, that is less than equal to m n minus 1. Okay, so from this you can conclude that n must be greater than equal to m plus 1, or you can say n minus m must be greater than equal to 1. And for these value, we know that our gamma function is well defined. That means gamma of n minus m is well defined. Well defined means finite value. While we are saying that we are talking about the integers, since m is an integer, n is an integer, so m minus n plus 1, with the help of this, we can say that it will be some negative integer. So it will imply that sine pi of m minus n plus 1, this will be nothing but 0. Okay, so if it will be 0 and denominator is a constant, so we can say that 1 by m minus n plus 1, this value will be 0 for all m equal to 0, 1, 2 and up to n minus 1. Okay, so till n minus 1, we can say that this series terms or denominator is 0, or denominator is infinity, and the whole quantity will be 0. So our series is going to be start from j minus nx, that is m will be starting from n to infinity minus 1 to the power m, x by 2 to the power 2m plus n divided by m factorial m minus n plus 1. So here it should be minus n. So now you know that from where your series is starting, and you know that your j and x is starting from n equal to 0 to m equal to 0 to infinity. Now you need to here just rewrite, or you can say manipulate it, in the sense that our series is will start from m equal to 0 to infinity. So try from here, then we will discuss. So let us proceed. So since we want to start the series from 0 to infinity, so what we will do, we will substitute m as m minus n so that it will start from 0. So k 0 to infinity. So we want to start with k. So here k will be k minus, let's say k minus n. So k plus n. So here k plus n. We are considering k equal to m minus n. So that it will start from 0 to infinity. So from here you will get k equal to m plus n. So it will be x by 2 times. So let me simplify in this manner that x to the power 2 k plus n minus n divide by m factorial 2 to the power 2 times of k plus n minus n gamma of k plus n minus n plus 1. So this will give you the series k 0 to infinity. If you will simplify this a little, so let me do a little more precise in this calculation in the way we can take from here minus 1 to the power n outside, and this will give minus 1 to the power k x to the power 2k plus n divided by m factorial. Sorry, here we have to put k value of k. So this will give you k plus n factorial. So this will be k plus n factorial 2 to the power 2k plus n divided by k plus 1. So till now, what we want to show, if you remember, here it should be k factorial, and here it should be k plus n plus 1 to relate it with g and x. So for that, what we will do, minus 1 to the power n k 0 to infinity minus 1 to the power k. We do not have any problem with the numerator. It is the same that we want. But in the denominator, we have to be a little precise. So how? So let me just combine this x by 2 in the numerator. Let me keep it like this. So this will be k plus n, k plus n minus 1. So let me write it here. So suppose I am saying k factorial plus k plus n plus 1. So what I'm saying, k plus n factorial into k plus 1 can be written as k plus n, k plus n minus 1, k plus n minus 2, and this series will go up to k plus 1 into k factorial into gamma of k plus 1. So this will imply that this these terms and these terms. So k factorial will left outside. So this will give you gamma of kn plus 1. Reason is gamma of alpha plus 1 is equal to alpha gamma of alpha for all alpha. Okay. So from here we can say that our we get the series into this following form, and this will nothing but jnx. So this is true for all n positive integer. Okay. So here we have shown that this j minus nx is equal to minus 1 to the power n jnx. In the next property, or you can say in the next question, we use some different property to show that d by dx of x to the power n j n a x is nothing but a x to the power n j n minus 1 x. And since it is valid for every n, so let me write it here alpha. because we generally use alpha as a parameter in our Bessel differential equation. So this will be J alpha alpha. Okay. So here this is a kind of the property we have done in the class. So here we are just replacing in the function x by ax. So what we need to do, either we can apply the chain rule or we can follow the process of Bessel function, the definition of the Bessel function. So try this one. So let me start with the definition of G alpha x. We know that J alpha x is the series m0 to infinity minus 1 to the power m x by 2m plus alpha divided by m factorial gamma of m plus alpha plus 1. We know that this is the series. So what we can do, we first write J alpha ax. Then we can establish the relation. So here I think there is a typo. It should be J alpha minus 1 ax. So let me correct it. So this will be ax. This should not be changed. So J alpha ax will give you m 0 to infinity minus 1 to the power m ax by 2. I am just replacing x by ax. So this will be 2m plus alpha divided by m factorial m plus alpha plus 1. So we want to differentiate it and multiply this first of all x to the power alpha, and then we'll want to differentiate it. So what we will do, x to the power alpha g alpha ax. So this is m 0 to infinity minus 1 to the power m. So we write explicitly a by 2 to the power 2m plus alpha, and here we may write x to the power 2m plus 2 alpha, because 1 x to the power alpha will come from here. So divide by m factorial gamma of m plus alpha plus 1. So what we want to do, we want to differentiate it with respect to x. So this will give us m 0 to infinity minus 1 to the power m a by 2 2m plus alpha, and since we want to differentiate with respect to x, so this will give us 2m plus 2 alpha 2m plus 2 alpha to the and x to the power 2m plus 2 alpha minus 1 divided by m factorial m plus alpha plus 1. Now we want to relate this with alpha minus 1. Okay, so what we will do, we will take out a, since we want a outside, and next what we will do, we take out x to the power alpha, we want it outside, and we write the rest expression and try to rearrange it in some manner so that we can get our required property. So what we can do from here, this will be minus 1 to the power m, and here it will be, since we have taken 1a outside and 1 2 will be cancelled out from here, so let me just write it, a x by 2 to the power 2m plus alpha minus 1. One factor is this, and 1 2 will be cancelled out, this will be m plus alpha divide by m factorial, and we write this gamma function as m plus alpha into gamma of m plus alpha. As I told you that gamma of any z is z minus 1, or you can say z gamma of z plus 1 can be simply rewrite it as z gamma of z for all z. So this is our property of a gamma function. So a x to the power alpha m 0 to infinity minus 1 to the power m ax by 2 2m plus alpha minus 1 and divide by m factorial gamma of m plus alpha minus 1 plus 1. So clearly this expression look like a j alpha minus 1 of ax. So this we want to prove, that we have proven. So the next question is question number 3. This is somewhat different from the above, but ultimately we are going to use the properties of the Bessel function. So find the differential equation that is satisfied by the function fx equal to under root pi x j half of x for x greater than 0. We want to find out the corresponding differential equation to which this function will satisfy. So we know that the Bessel function with the help of this j half x, which is going to be satisfied. So we want to follow that approach. So try this one. Okay, let me before tell you one another approach to the above question. So let me remove this one first. What can be the other approach? Sorry. So this is our method one, you can say. I told you one another method, that is chain rule. So can we apply that here, since we are talking about J and AX? So you try this one, Richima, then we may discuss it further. So let us focus on the third question. You may try with the chain rule. So here we want the differential equation to which this function will satisfy. Try one, this one. So let us discuss it. So what we can do here, we know that j half x, that is, so there will be two approaches. Method one will be like this. We know that, excuse, we know that j half x, that is under root 2 divided by pi x sin x for x positive, is a solution of the Bessel differential equation for alpha equal to 1 by 2. So what is the Bessel differential equation? X square y double dash x y dash plus x square minus 1 by 4 y equal to 0. So we know this thing, that this is the solution of the following Bessel equation. Next, we have given that fx is equal to under root pi x into j half of x. So you can say that this method one will start from here. So either the way we can go directly by multiplying this by putting the value of j half of x. Other ways around is we can substitute this value into the given differential equation. So let me mention how. So here this will give you under root 2 sin x. If you will substitute the value of this j half, so this is under root 2 by pi x sin x. So under root pi x will cancel out, and fx will be under root 2 sin x. If you know that, if you remember that when we are solving the differential equation for constant coefficient, then cos x and sin x will occur only in the case of solution if we have a complex roots of the auxiliary equation. So what can be the auxiliary equation in this particular case? So if sin x is a solution, if it is a Li, so obviously it's a single solution, so it's a Li solution, then what will be its other combination, that is cos x, second Li solution. And corresponding to this sin x and cos x, we have some equation. So let me recall it first. Y double dash plus my equal to 0. Here m is any positive integer. Then what we can say, our let me write lambda. So m square plus lambda will be 0. This will be my auxiliary equation. So let me just write it, auxiliary equation. So this is our auxiliary equation, which has root m equal to plus minus. Okay. So sorry. In this scenario, what we may write. So here you may also write lambda square, where lambda is some non-zero. So obviously it's going to be positive. Okay. So lambda square. So lambda is any complex number. So let me just say it here, that lambda y and lambda is any positive integer. So this will give you m equal to plus minus iota under root lambda, and this will imply negative. This will imply that our yx will be some C1 cos under root. Since it's from here you will get say, lambda x plus C2 sine under root lambda x. So this will be your solution. So here you are getting the sine x as solution, and this constant will not matter. So from here you can directly guess what can, if lambda equal to 1, if lambda equal to 1. So there is a typo. So if lambda equal to 1, then your solution will be yx equal to c1 cos x plus c2 sin x. So these two sin x and cos x will be the Li solution, and any constant multiple of them is also a solution. So what you can say that that fx corresponds to the differential equation f double dash plus fx equal to 0, 0 is the required differential equation. So this will be our required differential equation. Okay, this is our method one, our approach one. What can be the other side? We know that j half x is the solution of a given Bessel's equation. So what we will do, we will substitute the value of j half x in the terms of fx and that under root pi x. So from here we will do that fx is under root pi x sin x, sorry, j half x. So from here we will do we substitute j half x as fx by under root pi x. Since our fx, this j half x will satisfy our this Bessel equation star. So we will calculate this y double dash, y dash, and y in terms of fx, and then we'll substitute into this, and we get the required differential equation. So what we will do, we will differentiate it. Its derivative will be f dash x divided by under root pi x minus 1 by 2 under root pi x to the power 3 by 2 fx. This is our first derivative, j half double derivative. So this will be f double dash x divided by under root pi x, and the next will be, next you will get from here, if you differentiate under root x, you will get the similar quantity, and here if you differentiate f, so I can combine them 1 by under root pi x to the power 3 by 2 f dash x. From the product rule, if you will differentiate x, then you will get with positive sign 3 by 4 under root pi x to the power 5 by 2 fx. So this is your j half x, j half dash x, and j half double dash x. Now we can substitute these values into the given differential equation, because we know that x square j half double dash x plus x j half dash x plus x square minus 1 by 4 j half x is 0. We know this thing. So this will imply, if we will multiply this with x square, so x square into this j half x. So I am writing, skipping one step. So x square minus half. So this will give us x to the power 3 by 2 divided by under root pi f double dash of x. Then again I'm multiplying x square with the second term. So this will give us under root x by pi f dash x. If you multiply this with third term, that is x square, so this will give us x square minus 5 by 2, that is x to the power minus half. So this will give you 3 by 4 under root pi x fx. So this is your first term. Now second term will correspond when you multiply with x. So this will give you under root x divided by under root pi f dash x. Next, if you multiply x with this, so it will get 1 by 2 under root pi x fx. Next is x square minus 1 by 4 j half x. So if you multiply with x square, so first term will be square minus half, that is 3 by 2. So x to the power 3 by 2 under root pi into fx. Next is minus 1 by 4, that is minus 1 by 4 under root pi of x fx. This will be 0. Okay. Now we have to think which quantities, which powers are cancelling out simply. So let me use a different color. So if you will observe here, x to the power 3 by 2 is there. Next to x to the power 3 by 2 is here, but here it is fx. So we can leave it. So next is, what can be the next f dash x? If you can see here, under root x by pi. Similarly, this is positive sign. So these two will cancel out. Okay. Next one is this one, fx, this one half, and this one 1 by 4. So half is 2 by 4 minus 1 by 4 minus 3 by 4. So these three will cancel out. Now you're left with only x to the power 3 by 2 divided by under root pi f double dash x plus fx. This will be 0. So you will get this one. Next, because x is greater than 0, thus what we will get? We will get f double dash x plus fx is equal to 0 is the required differential equation. Okay, so let me write the next question. Question number 5. In this, we have to show that the integral 0 to pi by 2 under root pi x j half of 2x dx is nothing but exactly 1. So I'm just giving you a hint. So there is not much bigger calculation in this. You just need to recall what is the value of j half x, and in the place of in the place of x, you have to substitute as 2x, and then you have to calculate this integral with the help of left hand side. Then you will get 1. So try this one. So let us start solving this one, or you can say proving this one, since we want to show it. Prove. We know that j half of x is under root 2 pi x sine x. So j half of 2x will going to be under root 2 by 2 pi x sine 2x, which will give us under root 1 by pi x into sine 2x. So we'll substitute this value in the left hand side. So left hand side is 0 to pi by 2 under root pi x j half 2x dx. So this will give us 0 to pi by 2 under root pi x 1 by under root pi x sine 2x dx. So under root pi x will cancel out. We will left with the integral 0 to pi by 2 sine 2x dx. Now, so we know that sine 2x is minus cos 2x divided by 2, 0 to pi by 2. So at pi by 2, this will be minus cos by divided by 2, and at 0 will be minus cos 0 divided by 2. So this will be your value of the integral, and cos pi is minus 1, so it will be half, and minus minus will plus, this will be again half. So this will be 1, that is RHS. So you have proven what it has been earlier, it had been asked to prove. So the next question is kind of related to the recurrence relation, to the use of recurrence relation to find out the um, values of, or you can say to show the proof of the following. Next is question number 5, I think. So earlier one was 3, and this should be 4. Question number 5, make use of recurrence relations to show that a part d over dx of x square j 2x is x square j 1x. Next one is 2 times of d by dx of j2x equal to j1x minus j3x. So we need to show these two proofs with the help of the recurrence relation. First, you may try at your own, then we may discuss it. Let us start with this first part. So, proof A part. So, let me recall that d by dx of x to the power alpha j alpha x is equal to x to the power alpha j alpha plus 1x. This is holds for every alpha and every x. And next is j alpha x with negative sign x to the power minus alpha j alpha minus. So these two with negative sign. So these two relations you know. So you have to make use of these two relations in some sense to get to this following inequality. So I have given you one hint. Let us yourself try once more. I'm sorry, there is a typo. This will be -1 and this will be +1. So I hope it is clear now that we have to use the first one. So what is the alpha here? Alpha is 2. So for alpha is equal to 2 in 1, what you will get? D by dx of x square j2 x is x square j2 minus 1 x. So which will be nothing but x square j1 x. So it is somewhat straightforward. Now in the next property, what you have to do, you have to calculate the derivative of this j2x in terms of j1x and j3x. So for the b part, we need to calculate derivative of j2x in terms of j1 and j3. If you will observe here, for let me write it, for alpha is 2 in 1 and 2, this will give you that d by dx of x to the power 2 j2x, this will be x to the power 2 j2 minus 1, that is j1x, and d by dx of x square j2x, this will be x square j, can we use this one, j3x? No, because we want here j2x, not the terms of x square. X square we should be cancel out in some sense. So what we can do here, so we want to first, let me write it here, we want to cancel this square. So what we will do, we will simplify this in the sense generalized formula, that equation 1 and equation 2, in the sense the following: we will calculate derivative of left hand side and put in this equation. So what will be the derivative of the left hand side? If you will try to calculate it, it will be x to the power alpha j alpha dash x plus alpha x to the power alpha minus 1 j alpha x equal to x to the power alpha j alpha minus 1x. This will be your equation number 3. Next is x to the power alpha j minus alpha j alpha dash x plus, in fact, minus alpha minus alpha minus 1 j alpha x, x to the power minus alpha j alpha plus 1x. Okay, so if you will multiply here x to the power 2 alpha on whole, in whole the equation, so you will get equation number 4 is multiplied by x to the power 2 alpha. So this will give you x to the power alpha j alpha dash x minus alpha alpha minus 1 j alpha x, x to the power alpha j alpha plus 1x. I hope it is somewhat clear in the sense that both the equation 3 and 5, what we can do, we can add them and we can take x common in some sense. So you will get 2 times of x to the power alpha j alpha dash x. Okay, so if you will add them, this quantity and this quantity will be cancel out. So you will left with x to the power alpha j alpha minus 1x plus j alpha plus 1x if I will take this x to the power alpha common. Now you know that these inequalities is hold for every x greater than 0. So this holds for every x greater than 0. So what we can do, we can cancel out this x to the power alpha and we will left with the 2 times of j alpha dash x is equal to j alpha minus 1x plus j alpha plus 1x. So from here, if you will rewrite it, d by dx of j alpha x is equal to alpha minus 1x plus alpha plus 1x. Now you got your formula. So put alpha equal to 2, then you will get 2 times of d by dx of j2x is j1x plus j3x. Now you can verify what do you want. You want this one. So here there is some typo because here it's minus. So this will be minus. So this will be minus minus, and the conclusion will be also minus. So we have proven the relation. Next question is we want to calculate the values of the value of the integral. Question number, this is 5. So the next one will be this number 6. Calculate the value of the integral x cube j 3x dx in terms of j0, j1, j2. It might be asked for some j4, j5, j6, but here I'm asking for j0, j1, j2. So try this one. So here we want to calculate the value of J3 in terms of J0, J1, J2. So if you will observe that here the index is decreasing. We want to calculate in the recurring decreasing index. So what we can do, let me recall the formulas, uh, recall the properties. X to the power alpha, J alpha x is x to the power alpha, J alpha minus 1x. One property is this, and another property is x to the power minus alpha, J alpha x is minus x to the power minus alpha, J alpha plus 1x. So observe from here what you want. You want this to be in some decreasing sense. So this is the hint. You can try first. Since we want to integrate the following quantity and we parallelly want that our index should be decreasing. So if you will observe that here, if you will write, consider this output, then it will be some d by dx type of form, and you can apply the integration by parts. So doing this smart work, what we will do, x cube j3x dx. So if here alpha plus 1, there should be minus alpha. So to make that, what we will do, we will add 3 plus 2 minus 2 j3x dx. Now by this equation number 2, for alpha equal to 2, we will get x to the power 5 d by dx of x to the power minus 2 j2x. So you got one decreased value from index 3 to 2. So if you will apply that integration by parts, so this will be your first function and this will be your second function. So first function will take outside and will integrate the second function. So this will be, and moreover, there would be a negative sign. So this will give you minus x square j2x with negative sign integration of d by dx of x to the power 5, and with this quantity minus x square j2x. dx. So this will give you x cube j2x with negative sign plus integration 5 of x to the power 4 x to the power minus 2 j2x dx. Again, we want index to be decreased and we want the derivative here. So what we will do, here it is 2, so it should be minus 1. So for this, minus x cube j2x plus 5 x to the power 3 x to the power minus 1 j2x and dx. So this will give you minus x cube j2x plus 5 x cube d by dx of x to the power minus 1 g1 of x dx. So this will be your first function and this will be your second function. So from here, minus x cube j2x plus 5, first function will be as it is. Second function will give you x inverse g1 of x. Next is with negative sign, 5 will be as it is, the derivative of this x cube and this quantity with negative sign. So here will be again negative sign. So minus x to the power minus 1 g1 of x dx. So this will give you minus x cube j2 of x minus 5x square g1 of x and with positive sign 15 x square x minus 1 g1 of x dx minus x cube j2 of x minus 5x square g1 of x plus, since here it index is 1 and here should be 0, so for that we will do 15x g1 of x dx, and or you can write here x to the power 0. It will be more convenient to see. So x to the power 0, 0 plus 1x dx. So this will give you minus x cube j2 of x minus 5x square j1 of x plus 15x with negative sign d by dx of with negative sign j naught x dx. First function, this will be second function. So this will give you minus x cube j2 of x minus 5x square g1 of x and with 15x minus j naught of x minus of 15 d by dx of x minus j naught of x dx and minus x cube j2x minus 5x square j1x minus 15x j naught x and with positive sign 15 j naught x dx. Since it's an indefinite integral left, so there will be some constant addition. So this will be your integration of j cube integration of x cube j 3x dx in terms of x square in terms of j2x and j1x and j naught x. Here we cannot integrate further. The reason is, you know that j naught x will be, we have to put the alpha to be 0 in the given equation. So j naught x will be some series kind of thing, m0 to infinity minus 1 to the power m x by 2 to the power 2m divided by m factorial m plus 1. So it's again a series, so you have to integrate this one. So I'm leaving this part. So this will be your in terms of J0, J1, J2. So in the next question, what we are going to do, this is a simple application of Rawls theorem. So question number 7, I think. Yes, 7. So show that Jn plus 1 has a root between any two consecutive roots, or in fact consecutive positive roots of Gn around x equal to 0. So as I told you, this is a simple application of Rawls theorem. You have to use the above mentioned identities of differentiation of Gn. So try this one. So let us do is proof. Let x1 and x2 be two positive roots of g and x. So if these are two positive roots of g and x, so without loss of generality, assume x1 to be less than x2. So if these two are root, then g and x1 must be, so this will imply g and x1 must be 0 and g and x2 must be 0. So if these both two are 0, then x to the power minus n g n x1 will be 0 and x1 x to the power minus n j n x2 will also be 0. Now what I'm going to do, I'm consider some gx to be x to the power minus n j n x. So clearly we know that this gx is a continuous function on the interval x1 to x2. Next is, this is your first one, and next one is gx is differentiable on x1 to x2. Next, third one is g at x1 is 0 and g at x2 is 0. Now clearly all the conditions of Rawls theorem has been satisfied. So therefore by Rawls theorem, excuse me, so by Rawls theorem, what we can say, there exists a constant c between x1 to x2 such that the derivative of this x at c will be 0. So that means d by dx of x to the power minus n j n x at x equal to c, this should be 0. Now you know that this is nothing but x to the power minus n j n plus 1 x at x equal to c equal to 0. So that means c to the power minus n gn plus 1 c will be 0. Because c is a positive, so this will imply that gn plus 1 at c must be 0. So that's what we want to show, that in between any two consecutive positive roots of jn, we get a root of gn plus 1 that we have shown. In the next question number 8, what we want to do, we want to calculate the value. Question number 8, find the value of x j half square x plus x j minus half square of x. So it is not that much difficult. So you may try at your own first, in the sense you can uh, put the value of, recall the value of j half x and j minus half x, then you have to square and multiply with the x, then you have to calculate the exact value. Try this one. So let us discuss this one. We know that j half of x is under root 2 by pi x sin x. Okay, so from here, what you can do, j half square of x is 2 by pi x sin square x. So this will give you x j half of square x 2 by pi sin square x. Suppose this is your equation number 1. Now for the next part, j minus half of square x is under root 2 pi x cos x. So what you will do, sorry, this is j minus half x value, not its square. Now you will do its square, so you will get 2 by pi x cos square x. This will give you x j minus half square x 2 by pi cos square x, question number 2. We want to calculate the value of its addition, that is x j half square x plus x j minus half square x. This will give you 2 by pi sin square x plus cos square x. So this will give you, since sin square x plus cos square x is 1, this will give you exact value as 2 by pi. So let me write it in the way. So this is equal to 2 by pi. Okay. So the next question is question number 9. Write j 5 by 2 comma j minus 5 by 2 in terms of elementary function. Elementary function means some fundamental functions that you are well aware about it. So try this one. You have to apply the property of the Bessel function that we have reduced in this third or fifth, you can say. So you may try this one. Otherwise, we will discuss in some time. Or let me just first write those properties so that you can do it at your own first. So we know that from equation number, we use the equation number 3 and 4. Okay. So what are the equation number? This 3 and 4. Let me take from there. So this is equation number 3 and 4. We are going to ultimately use them. So this is your equation number 3 and 4. So recall 3 and 5 from question number, which was the question number? I think 5. So it's a 5. So we recall the equation number 3 and 5 from question number 5. So with the help of this, what we are going to do, we want our g half to be written in the well-defined function or elementary function that are, you can say, you have to calculate 5 by 2. So what you can do, you can decrease it to 3 by 2, then 1 by 2, and you know that the value of j half of x. So we are going to do the same thing. So for that, let us first observe how we are going to use it. So we are going to use it in the manner we want decreasing, not differentiation. So what we will do, we will subtract this equation 3 minus 5. This will give you, you get, if you will subtract it, you will get alpha x to the power alpha minus 1 j alpha x. 2 times of this is equal to x to the power alpha j alpha minus 1 of x plus x to the power alpha j alpha plus 1 of x. So these two quantity you will get, and when you will take x to the power alpha minus 1 common, and alpha minus 1 is, you can say x is a non-zero quantity, so you will get from here that j alpha x is x by 2 alpha j alpha minus 1 of x plus j alpha plus 1 of x. So this is you're going to get. So try this one. So what we want to do, we want to, since we want to decrease the value, decrease the index from 5 by 2 to 3 by 2 to 1 by 2, we write g alpha plus 1x in terms of alpha and alpha minus 1x. So this will be 2 alpha by x j alpha of x minus j alpha of minus 1x. So put alpha to be 3 by 2. And you will get j 5 by 2 of x, 5 by x. We are putting 3 by 2, so it will be 3 by x, 3 by 2 of x minus 1 by 2 of x. Okay. Now again we have to decrease this 3 by 2. So what you will do, this is 3 by x, and you will rewrite it as 1 by 2 plus 1 of x minus j half of x. So this will give you 3 by x, 1 by x, j half of x minus j minus half of x whole multiply by 3 by x minus j half of x. So this will give you 3 by x square minus 1 of j half of x minus 3 by x of j minus half of x. So this is your value of the following, and you know the value of j half of x and j minus half of x, that is under root 2 by pi x whole multiply by 3 by x square minus 1. This is sine x minus 3 by x cos x. I think this will be your first answer. And the next one will be, so we have to calculate j minus 5 by 2 in the similar manner. So what you will do, you will write j, this formula, in terms of j alpha minus 1x. So again you will get, so let me first write it. So j alpha minus 1x, this will give you again 2 alpha by x, j alpha x minus j alpha plus 1x. So we rewriting it because this one. So what you will do, put alpha equal to, what we have to put, minus 3 by 2. So if you will put minus 3 by 2, so this will be minus 5 by 2 x minus 3 by 2 minus 3 by x, j minus 3 by 2 of x minus j minus half of x. If you will solve it, minus 3 by x, you may rewrite it as minus half minus 1 of x minus j minus half of x. So this will give you minus 3 by x, and this will give you minus half. So minus half means minus 1 by x, j minus half of x minus j half of x minus j minus half of x. So ultimately you will get 3 by x square minus 1, j minus half of x minus, or you can say plus 3 by x, j half of x. So this will give you 3 by, where we will put the value of this j half and j minus half. So this will give you 3 by x square minus 1 cos x plus 3 by x sin x. So this will be the value of your asked second validity. Let me check it. Yeah, this is correct. So these two values we have been asked to calculate, and we have calculated these two. So that's all for today's lecture. If you have any doubt, then you can ask. Otherwise, let's complete this session. Okay, since there is no doubt, so let's meet on the next Tuesday on the same time, 6 to 8, for other week 8 lecture, I think. I'm sorry, week 7 lecture. So thank you.